for creating dynamic 3D content and for rendering that content on a variety of displays, including the latest widescreen monitors and also the newer glasses free 3D monitors, the auto stereoscopic monitors, but also other types of displays, including holographic displays. But it's not focused just at those more exotic displays. It's focused at anybody who wants to create 3D content for whatever it is and whatever sector they might be in. This little video here, we're now looking at the Viva3D application, is an example of the Viva3D interface, and as you can see, every object here is being rendered in real time. And for example, you can just simply click on an object, move it around, resize it, place it. You can see the shadow is tracking, so it's a completely 3D and real-time system with some fairly advanced facilities. It runs on low-power computers. It runs extremely well on the AMD A8, A10 and A12 APUs. We've just started testing it on Ryzen Mobile, and the results are spectacular. We're getting about 3 times the frame rate on very, very complex scenes that we would normally see on an A10 or Intel i5 with integrated NVIDIA graphics. So the cost of the hardware to play this back in real time is reducing, and as I said, creating content, moving content, building up your scenes, your advertising content or your information displays or educational content is becoming easier. So let's just get this going. So there are the animations in the scene. Here in the middle we can see some text. The final part of the text is the real time, the actual time. You can display 3D text which is linked to external RSS data feed or database links or whatever you want. It's a very flexible system based on the original Viewpoint 2D software used in a large number of airports and other information display applications and industrial applications for 24/7 usage, so it's very, very reliable. You can see here we've got objects which are bouncing. We've got position activated objects like the Q stick here, which is hitting the ball back and forth. It's very, very easy to actually animate objects. For example, the 2 little cue balls there, the 3 ball there, if I just stop the camera animation, the 3 ball there, if I just move that down a little bit, double click on the object and simply select one of the animations, bounce, and we can see that's now bouncing, and we can adjust the parameters, the frequency, the start and end positions, whether it bounces back, etc., etc. So basically you've got a system which is extremely easy to create content. You've got environmental reflections, dynamic data linking, very fast rendering on even a $90 tablet computer with a little built-in GPU. So it runs on very low-cost hardware, so you could dynamically display 3D information of whatever nature remotely throughout hundreds of screens, for example, or display points. As you can see here, you've also got animated objects like the fish. Some of the fish has got built-in animations. Some other fish models have no animation, but the software will actually animate the vertices in the vertex shader to provide an animation for objects that don't have animation. And that's it. So let's just get the camera going again. Now we're going to switch it over to 2D plus depth, which is a typical type of display format for the Demenco, the Philips Wow VX and Demenco monitors. And there you can see it's now rendering the background in grayscale, background without objects, and also in color being rendered without the objects, which gives the best results for the look around type of effect on a 3D glasses free monitor. In addition to 2D plus depth, it will render the 9 or 5 to 9 images for auto stereoscopic, again in real time, and it will do the interleaving for the monitor. And as you can see here, we've got all the features to adjust a wide range of 3D facilities. The disparity, the stereo displacements, lambda, sigma. It's fully compatible with the Open CV 3.3 library, which we've tested. It's working extremely well. We can rapidly, because the entire code base we have in-house, we can very rapidly add facilities. Last year we added facilities for stereoscopic vision, so you can add stereo camera to this and actually have an external 3D environment extruded and displayed within the 3D scene for whatever purposes, medical imaging or any other type of imaging application. So it's flexible, it's reliable, it's 24/7, and we're looking for any applications. I hope this is of interest. Thank you.